In this video, we will be discussing statistics and the distribution of data. We will be focusing on histograms. By the end of this video, you will be able to read a histogram. So histograms show data in intervals or ranges. The height of each bar represents the frequency of the values in that range, and it does not show individual data values. Let's take a look at this histogram here. It says, how is this graph different from bar graphs you have used previously? So a bar graph has gaps between the bins. It records categorical data. So it might be eye color, favorite music, favorite pizza toppings. And a bar graph looks more something like this, where I've got a bin here, and I've got one category. I've got a bin here, got another category, bin here with another category, but there's spaces and each bin represents a specific category. Whereas a histogram has no gaps between the bins, it's on a continuous number line. So if I look up here and see that on my x-axis, the numbers just go continuously. There's no blanks, there's no spaces. The bins are touching right next to each other. So it's continuous. What information does a histogram display? Well, in this case, it's displaying the number of floors in the tallest buildings in the Twin Cities. And I can tell that because of my title right up here. And then it's broken up into number of floors and number of buildings. Still looking at the same histogram, says how many bins are shown? Well, there's 1, 2, 3, 4, 5 bins. Are all of the bins the same size? Yes, they're all the same size and they measure 10 floors. The first bin measures from 10 floors to 19 floors. The second bin measures from 20 floors to 29 floors. So this line here is the cutoff. So in this case, the 20 goes over here, the 30 into this one, the 40 is the start of this one, and the 50 is the start of this one. What does the height of each bar represent? Well, the height of each bar represents the number of buildings having that many floors. For example, the first bin goes up to 8, so it goes up to right here, and that means that there are 8 buildings that have somewhere between 10 and 19 floors in it. And the second one goes up here to 26. So that means there are 26 buildings that have somewhere between 20 and 29 floors in it. Let's take a closer look at these bins. Describe the range of floors included in each of the bins shown on the horizontal axis. So in the first one, we have 10 to 19, and there are 8 buildings in there because, like we said before, this goes up to 8 and it's representing the number of buildings. In the second bin, we have 26. And again, the top one is cut off here at 26, and that's representing the number of buildings. Third bin, 16, because again, bin stops at 16, and that represents the number of buildings. Fourth bin has 5 buildings, and the sixth bin has 4 buildings. Still working with the same histogram, let's take a look at these questions. If a new building was constructed in one of the Twin Cities that had 20 floors, which bin would change? And how would it change? So the second bin is going to increase by 1 building because it says had 20 floors, and the range that has 20 floors in it is this right here. And so we're looking at that bin. And how would it change? It's going to increase by 1. So instead of 26, it would go up 1 to 27. Can you determine how many buildings have 31 floors? Well, No, we can't, because as we said before, these are ranges, and the data is somewhere within that range. We don't know specifically. So here it says the bins are a range of data. The number of floors can fall anywhere between those two numbers. And is it possible to determine the number of buildings that have more than 35 floors? And again, the answer would be no. The bins are a range of data. The number of floors can fall anywhere within that range, and you can't determine exact numbers. So I know that more than 35 is going to fall somewhere here, but I don't know exactly how many in this range here are 35 or 34 or 33 or 36. So I can't tell exactly. Is it possible to determine the range of the data from the histogram? Why or why not? And again, no. We can't figure out the exact range because we don't know where the data actually falls. We just know it falls somewhere within that specific range. You can't determine where the exact data falls within the ranges. Let's take a look at this histogram that shows us data from the national ACT exam. So first we're going to look at the frequency of the scores for each range. So first I'm going to look at my range of 1 to 5, and it looks like there was 1 score. And 6 to 10, also 1 score. From 11 to 15, looks like there are 17 scores. From 16 to 20, looks like there are 34 scores. From 21 to 25, looks like there are 28 scores. From 26 to 30, looks like there are 16 scores. And from 31 to 35, it looks like there are 3 scores. And again, I'm getting my frequency by where the top of the bin ends up. And then my label matches my y-axis over here. How many scores were included in the data set? Well, if I add up all of my frequencies, I come up with 100 scores. How large is each range of data? Well, it is a range of 5. Because if I count 1, 2, 3, 4, 5, that's 5 numbers. If I go 6, 7, 8, 9, 10, that's another 5 numbers, and so on. So each range has a gap or a space of 5. Where is the gap in the data? Well, according to this, there are no gaps in the ranges, but I don't know between the actual specific data. So all I can really put here is no gaps between ranges. Because again, I don't know specifics. I can just go by what I see on my histogram. Where is the data clustered? Well, based on here, it looks like a lot of the data falls kind of right in that area. So I would say between ranges of 11 to 15 to 26 to 30 looks like where a majority of my data is grouped or clustered together. So again, still looking at this ACT histogram. What range has the highest number of scores? Well, it looks like the range of 16 to 20, because that is my tallest range up here. What has the range of the least number of scores? looks like over here, that's going to be right in there. So we have two ranges. So ranges of 1 to 5 and 6 to 10. How does the number of scores between 11 to 15 compare to the number of scores between 26 to 30? Well, 11 to 15 had 17 scores. 26 to 30, we said, had 16 scores. So that means that the 11 to 15 range has one more score in it. How many people scored 25 or less on their ACT? So I'm going to look here at, here's my 25, and less would go this direction. So when I do that, I count up 81 scores, or 81 people. What shape, or what is the shape of the distribution of this data? I would say it's fairly symmetrical, because if we kind of start low here, the peak's in the middle, and then we start to go down again like that. So I would say symmetrical.